I think we probably could spend more time on that, but in the interest of time moving forward, I just heard a couple of words there that resonated with me, and it's actually part of the introduction for Spence: speed, quality, and cost. So Spence is the CEO of Lilt, a machine-assisted translation platform that helps businesses, agencies, and translators and individuals optimize translation speed, quality, and cost. He will be speaking on the democratization of translation via the human-to-machine partnership. Spence, thank you.
All right, thanks a lot. This has been a lot of fun so far. So you want to take 15 minutes? I know we're a little bit behind. Or okay, all right, great. Okay, all right, cool. Yeah, so my name is Spence Green. I work at a company called Lilt, and yeah, I've been working on machine translation for about 10 years now. And more recently, I've been interested in how humans interact with machine translation systems. So, instead of talking about translation productivity and like post-editing, whatever, I'm going to give a little bit of a different perspective on this. And I'm just going to start with, I guess this is kind of an existential question. Like, sometimes it's helpful to think about, like, why do we do what we do, and why did we do what we did yesterday, and should we do the same thing tomorrow? And so why are we here in the language industry? Well, the reason is because of linguistic diversity, right? And that's a good thing. What do we get from that? We get art, we get culture, we get identity, we get wide ranges and forms of human expression. But what's the drawback is we get communication friction, right? So that's why the language industry exists, at least for me. And so I think the ideal function of the language industry should be reducing the friction in communication, all right? And so if that is really what we're trying to do in the language industry, we should celebrate diversity. And I think the language industry does a really good job of having people who really care a lot about language and usage and things like that. But as far as making information exchange frictionless, there's a lot of work to do. So like frictionlessness is really hard, and information you can think as a fundamental input to the economy, and fuel is a fundamental input to the economy too. And I don't know, sometimes when I'm filling up my car, I just marvel at this device. So if you just think about filling up your car and looking at this gas pump, I can take my US credit card, go to the station down the street, put it into this machine. There's financial innovation, a currency exchange will happen right away. There's information technology that's required to connect with my bank or the credit card network and verify my account. And that's before you even get to the whole oil and gas infrastructure that's pulling this substance from 10,000 feet under the ground and refining it, and then delivering it to this device for a very reasonable price. And what does that enable? Well, that enables frictionless transportation. So for the most part, I can take a credit card, get in a car, and I could drive to the Pacific Ocean from here if I wanted to. And really, it wouldn't be much of a problem. I'd just stick the card in the machine every time I needed some gas, and I'd end up at the Pacific Ocean. And translation just isn't frictionless. I can't just get a document like that. And it's like pretty hard to build this device and get oil and get gas and whatever. And I think we can do that for translation. And, oh yeah, there's industrial agriculture too. I guess there's corn here as well. So it's like really an amazing innovation. I mean, I guess it's a good thing that this is going to be going away pretty soon. But as far as it is right now, it's really incredible. So why is frictionless translation really important? Well, the reason is because there are a lot of people who are going to come over on the internet over the next 5 to 10 years, right? So this is the most recent map from 2016 of internet usage, and blue is so this is internet penetration. You see in sort of the global north, you have very high internet penetration, and then in the global south, very low internet penetration. So as of 2016, there are 3.9 billion people, and that's 53% of humanity who's not on the internet. And most of those people are in the global south, and they don't speak English. So they're in Latin America, they're in Africa, they're in the Arab worlds, and they're in East Asia. And these are people who should have the same access to information that the rest of us do. And that's, importantly, like those people actually matter. So they matter, morally and socially, but they also matter because they're a big market. And so this is the reason why the big tech companies are flying balloons and putting gliders up in the air. And SpaceX is going to put 4,000 satellites in space to get internet to these people. Okay, so if you just think about like the size of the language industry right now, and then try to have some proxy for demand. Well, there's just this astonishing statistic that of like the generic machine translation systems, 143 billion words per day in 2016 for just one of the public providers, right? And so let's just assume that's $0 per word. It's not $0 per word, but it's a vanishingly small amount of money that's made off of that. And then if you assume that you just charge a little bit for that 143 billion words per day, just a small amount, half a cent a word, you can fiddle with these numbers however you want. And so you assume that demand just goes away. A lot of that demand goes away. And if 94% of it goes away just by charging a half a penny per word, you still get a market size that's approximately the same as the entire market for text translation right now. So that's 8.5 billion words per day. And if more of the demand there's more residual demand, then the market gets bigger, all the way up to like 40%, and you can think about it being 10x bigger. Now this is a model, and you can change it. Maybe you make it 1/10,000th of a cent or something. But the point is that there's demand there that's not being met. Okay, so the question is how could we meet this demand, and why isn't it being met right now? Why do people just go to Google Translate instead of getting a good translation? I'm not saying Google Translate's not a good translation. I'm simply saying, like, why don't they go hire somebody to get a translation? Well, one way we could do this is to hire and train more translators. So this is like 8.5 billion additional words that are not being processed by the language industry right now. So you could hire and train more translators. Okay, well, how does that work? So people, basically they have to make some money so they can survive as a translator. And let's say they make $30 an hour, and they work 8 hours a day, and they do 3,000 words a day. Now, some translators do more than this, some do less, but still it's kind of the case that people believe translators do 2,500, 3,000 words a day. And so that works out to 8 cents a word. Well, that's too expensive, and these people are not going to be able to pay that. So the obvious thing that you do when you have a kind of a manual service that you need to increase the efficiency of is you get leverage from a machine. In this case, you get leverage from software, and that could be like if you're cutting wheat or something and you want to build a harvest combine. In this particular case, we're going to get leverage from software. So let's suppose this translator still has to make $30 an hour, and they're going to work 8 hours a day, but now they're going to do 8,000 words in a day because they're getting leverage from software, and that gets us down to 3 cents a word. Okay. And now let's assume that the machine translation quality is going to keep getting better. And, by the way, the gains are really, the whole 10 years I've been working on machine translation, it's just been amazing what's happened in the past year. So let's assume that, for a lot of content, machine translation is going to get better. And then it's going to, especially if you can customize it to whatever application you care about. We have a scenario where we do, say, 80% machine translation, and we reserve the high-value content, 20% of the content, for doing human translation. Well, that gets us down to half a cent per word. So, just with technology that kind of exists today, we can get to that price point. So we've got to, if we're going to get leverage from software to get the price down, how do we do that? I want to say one thing about artificial intelligence, which is, I think John did a great job of kind of showing the very intentionally crafted sentence from the Google paper and then what that turned into. It's basically still the case that like babies can do really amazing things and computers can do amazing things, and there's just like very little in the intersection, right? So babies, they can express emotions, they can learn languages, they can translate languages. When they're very young, they can develop fine motor skills and run around tossing a ball. Computers can't do that. What can computers do? Well, they can hold a tremendous amount of information in short-term memory. They can search through all the world's information in under a second. They can do math at an extraordinary rate. And there's very little stuff in the intersection. Like we know that both can recognize cats really well. So that's like one task that's pretty well solved. Okay, so I want to argue for a view of AI as augmentation. This is an old idea from the 60s from Doug Engelbart. And so you think of AI as something that assists a human to do a job. And I've recently become aware of some really amazing work that the AP is doing with AI. So actually, you think the AP, like, okay, old media organization or whatever, they've actually been buying technology from startups since 2013 to get leverage for their journalists. And it's really amazing. So what they do is they have to generate these earnings reports, right? When a financial quarterly report comes out, and they have to generate this earnings report. Well, that's really sort of tedious work. So they have technology that actually generates these from financial reports right now. And that's these two reports here are actually generated by a computer, and they show up on the AP Newswire. And so this frees up, as of 2016, it frees up 20% of their journalists' time, they estimate. Okay? And it provides 12x more earnings stories than they had before. And they're not laying off huge numbers of journalists. In fact, what this does is it allows the journalist to go engage in more complex tasks. So they give as one example, they took these people who historically were writing earnings reports and they put them on the Panama Papers. So it's like really complex tasks to figure out what's going on there. You know, there's no sort of like robot that's going to figure that out. So I want to say that really what the future is the augmented translator and what that's going to do for the unit economics of the industry. And the technology for this already exists. So there are kind of two parts of what you need for in the abstract to have a human-machine interface. The first is the interface itself that the human's going to use. And it's good to have an interface that's intuitive. If you want to empower a broad range of people, then it's good to have, sort of a modern way of thinking about interfaces is that they should be discoverable and they should be very intuitive. So I'll give you one example, and I don't even think this is the best or the final way that people are going to be interacting with machine translation or getting aid from artificial intelligence. But one that's really well known is predictive typing. So we all use this when we do a Google search, let's say, and you start typing a query and it gives you suggestions. Well, it's been known since the mid-2000s in the information retrieval literature that query expansion increases the relevance of results. Why? Because we have limited short-term memory and we're not always sure what we're trying to formulate as a query. So having the machine give us some alternatives, it's much easier to pick from an alternative than it is to write something down yourself. And then what happens? Smartphones come along and we're kind of clumsy with our digits and we can't really type very well on a soft keyboard. So you use predictive typing, not in this case to like write messages for you, but to do error correction while you're typing very quickly. And this makes people type faster and more accurately on a soft keyboard. Okay, well, it turns out you can do the same thing for translation now with machine translation. So my company has a product that kind of integrates with a lot of folks' interfaces for translation. And you can see this is a recent integration we have with one of our partners. Down at the bottom, this person's translating that, that Rickroll song from the internet and from German to English. And the machine translation system, every time they type a word, it gives them a new suggestion. So it retranslates from scratch, and it uses what they've typed so far as evidence for what to generate. Now, you can do this really well in a statistical system. It turns out you can do this really, really well in a neural system. So even this particular interface is going to get a lot better in the next year or so. And the important note about these interfaces is that billions of people, literally billions of people, know how to use this interface. And the types of tooling that we use for translation right now, it's not the case that billions of people know how to use it. So if we want to empower, if we want to empower a broader class of people, having an intuitive interface with the intelligent agent is really important. Okay, so the second part obviously is the agent itself. And so one obvious way that people design agents to work with machines is to learn from what they do. So machines can sort of passively observe what people do, and this in fact is what happens. There was a discussion about ad tech this earlier. So every click by every user of the internet ever is recorded, and machines learn from that what your preferences are, and they show you new ads. So it's pretty obvious you want to do the same thing for translation. People are translating all day long. Machine can observe what they do, and it can improve what it does. So here's an example of this in action. So you can see here there's a French sentence on the top. This user is going to start translating this sentence. And the machine translation system got this phrase, lonely rivers, wrong. I'll just wait till the animation finishes, and then you'll see it update. So you'll see when this replays, you'll see that the MT system gets this phrase, lonely rivers, completely wrong down at the bottom. So the human types lonely rivers, and now the system gets a new suggestion that's completely right, and the human does autocomplete. And now you'd see when the human says, I'm done with this translation, and it skips down to the second segment, the MT system's going to learn from that, and now they get a new suggestion, and they don't have to correct it again. So right now when people, for the most part, they work with MT, they have to correct mistakes over and over again. But now the technology exists where you don't have to do that anymore. It's going to learn from what the human does over time. And so you get improvements in two ways. There's this kind of iterative refinement between the human and the machine. There's a feedback loop. And we see these feedback loops all over the place now. They're in search engines. They're in ad tech. When you talk to your phone, we've all used this in our spelling corrector for a long time, but that exists now for translation. It does instant learning. So while the human works or while you give it data, it's going to learn exactly what it should be sort of adapting to. And importantly, this enables this sort of continuous loop where you have every business has a flow of information coming through it, and sort of this can be hooked into that flow of information to do continuous translation. Okay, so what does this partnership enable? Well, the first thing that you get out of it is you get faster human translation, but you also get more accurate machine translation. So the machine translation system is constantly observing what the human does, and this is going to give you higher quality for the task that you're working on. The second thing that it does is if you're a professional translator, it amplifies what the professional translator does. So instead of doing 3,000 words a day, maybe they do a lot more than that. And that enables new business models and new unit economics for translation. And the third thing that it does is that it empowers non-professional translators. So, it's a common fallacy to equate a bilingual with a translator. That's not true. But there are a lot of bilinguals, in particular in businesses, that translation is it's kind of cumbersome and it takes a little bit more time than they'd like. But actually, if they had a sort of efficient way to do it, they would do it. And so this is true of a lot of regional marketers. They get translations from their localization department and they want to tweak it and fiddle with it. And there's a demand amongst marketers now to just kind of do it themselves if they can do it very efficiently. There's also a lot of interest right now in community translation, so companies that have large user bases that are bilingual. You can think about this in e-commerce sites. They might be incentivized to just translate right on the e-commerce site the product listing instead of having to pay for it. You see this with product managers as well. But crucially, it also enables bilinguals in the developing world. So it's well known that machine assistance sort of there's sort of an expert effect in translation. It's a human performance task. You can't make somebody do 100,000 words a day, but you can increase their efficiency with machine assistance. But somebody who's not a professional translator, you can the relative gain in their performance as a translator can be more significant than a professional with machine assistance. And so these people in the developing world who might not have any professional translation education, but nonetheless can participate in translating into their own languages, this kind of technology enables that. Okay, so so it's kind of the question is, that sounds great, but what about the final translations that come out of this, right? So we've been doing some work recently with a large tech company. Okay, it's a very big company. They have a absolute river of data flowing through this company. And we've been doing some work on their production translation workflow. Okay, so they have a full quality evaluation that they do for every translation that they use in their business, and it's sort of an error taxonomy, kind of like QT21 or DQF, but it's their own. It has grammar, terminology tags, whatever. They have in-house translators. They use vendors too, but their in-house translators are post editors, so they've kind of gone completely to using machine translation years ago, actually. And importantly, they don't do a review step. So we've been doing some work with them recently on a language pair that's a little bit odd, which is German to Polish. And kind of the MT quality is not super great, but it would be for English to French or something. But nonetheless, these translators are translating about 700 words per hour. And here's what it looks like. So if you are a vendor and you give this company translation, it's going to go through this production quality control process. And their acceptance level is 2% weighted error count. Doesn't matter if you wrote the translation on parchment with a quill pen because that's your aesthetic. It goes through this quality control process. So we've been kind of experimenting with human post-editing and then with this augmented workflow that I showed you. And these are some recent results. So 1.08% error rate with post-editing and a much lower error rate with augmentation, about 30% of that. So the point is that it doesn't, this is not sort of post-editing and maybe errors are introduced or something like that. This is more thinking about the agent as an assistant to helping the translator do their work. And the final results, and we've seen this in a lot of different evaluations now, are really good. And for much of the same intuitive reasons that when you're formulating a web search, it kind of jogs your brain or gives you additional ideas to use to solve translation problems while you work. Okay, so what I've just talked about, it absolutely will happen. I don't know about the market expansion. I don't know what will happen in the industry. There's a lot of changes going on. But as far as the specific technology goes, this will happen. More non-professionals will be empowered, and this technology will be used broadly across the industry. The only questions are really how quickly will this happen and who will do it. Thanks.
Thank you.
Thanks.
Thank you, Spence. Well, I think we have our first two panelist questions. So let's get set up for the panel session. If you just take a quick moment. I have this. Are you going to use it? Is this for you?
No.
Sorry. All right. Just give us a minute while we set up. Sorry? Yes. Is this yours? Should I move the podium?
Yeah, just to the side of it.
This is all taped down a little bit.
It's okay, the table is
Okay, please. Steve?
Yeah, go ahead. Yeah.